Afternoon, ladies and gentlemen. Myself, Sumaya Israt Moin, lecturer, Department of Mechatronics Engineering, RET. Along with me, we have Shopnil Shahakotha and Sakib Hassan Choudhury as moderators to provide any sort of technical support to this session. Today, we are in the first day of International Conference on Automation Control and Mechatronics for Industry 4.0. Current time is 4 p.m. Bangladesh Standard Time. I would like to welcome all of you in the keynote session 3 of ACMI 2021. On this special occasion, we feel honored to have Professor Dr. Prahlad Vadakkepat from National University of Singapore as a keynote speaker ACMI 2021. ACMI 2021 has got new dimension to have a resourceful person like him. He is one of the resource persons in the Igniting Minds movement by Vijayana Bharati India, which is a program enabling students to shed conventions and think out of the box. So, dear audience, this is the time to welcome our honorable keynote speaker, Professor Dr. Prahlad Vadakkepat, with big round of applause.
Thank you.
Thank you for your appreciation. It's our immense pleasure to have Professor Dr. Mohammad Musharraf Hussain, Russia University of Engineering and Technology as session chair, and Dr. Manavendra Saha, UA Australia as a session co-chair of this keynote session. After the end of the keynote presentation, there will be a question answer session. All the audiences are requested to write questions in the chat box. Audience can also raise hand in Zoom after the end of the presentation. Now, I would like to request our honorable chair and co-chair to take the floor and introduce our honorable keynote speaker to the audience.
Anyway, I have already introduced. So anything from the Dr. Manav Saha, then you can say, then we can start.
Yeah, that's thank you very much, Professor Hussain. That's to introduce Professor Vadakkepat. Initially, we have an informal chat. I just like to add that's very interesting things going to happen, and we are going to enjoy that, particularly the Internet of Things and artificial intelligence and robotics options. That's it's very interesting in terms of my particular interest in research, focus on the application of IoT things for defense industry. That's I'm doing now. So I'm also excited with all others viewers to listen the masterpiece speech from Professor Vadakkepat.
Thank you. Good afternoon, and quite happy to be here. Thank you for inviting me for this conference. My very good friend, Mamun Abdullah Al-Mamun, is my neighbor for the last 20 plus years. So he has suggested my name to this conference. So I am thanking him as well. These are difficult times, but we are here. So let us take care of ourselves and everyone around us. I have taken some pictures from internet for the use of academic purpose only. I've been working in robotics and mobile robots and humanoid robots, and also AI, different aspects of it in terms of fuzzy logic, artificial neural networks, evolutionary algorithms for a long time since my master's. And also into something known as frugal innovation or grassroots innovation. This is very much part of me. And also I am an entrepreneur, did a number of startups, and lately a couple of companies came together and we have developed affordable emergency care ventilators. I have a couple of slides on that towards the end. Well, I'd like to start with this particular slide where the World Economic Forum October 2020 report states that by 2025, 97 million new roles can emerge. They'll be more adapted to the division of labor, which is new among machines, humans, and algorithms. So this is inevitable. So in Singapore airport, I don't have to really meet anyone to get into the airport. Everything is automated, and also many other places in the world. And more automation and intelligent automation is happening. And COVID has accelerated the pace of development because we need to keep the distance. And whenever distances have to be kept, we need to be careful about. So when new roles are there, but how much will be displaced? 85 million jobs will be vanishing from Earth by 2025. And this is something which is to be very careful about. And I would like to say, especially developing countries, have to be very careful about this. There are two aspects to it. One, the new roles will lead to new businesses, new intellectual properties and patents, and the financial flows. And if we don't act on time, those opportunities may not be there. That is one part of it. The other is to replace the lost jobs. We need to come up with ways to empower people, especially through the academic institutions and research organizations, wherein we have an increased responsibility to train, retrain, uptrain, or whatever reskilling, upskilling related aspects. So in Singapore, there is something called AI Singapore to facilitate a number of companies. So such initiatives will help us to tide over this situation. And I would like to say, artificial intelligence is not complex. Artificial intelligence is not Herculean. Anybody can learn it, except our biases are the hurdles. We need to really throw away the boundaries of different specializations. And what happens soon is that specializations will vanish and more interdisciplinary, multidisciplinary aspects are more dominating in natural, because especially with the new world that we are living in, a single specialization is not going to be helpful. And also educators and policymakers and researchers as well as students, we need to know what is going away and what is going to be of increasing demand. So data is going to dominate, AI is going to dominate. So that is in robotics, definitely. So we need to have more of this. And I know my colleagues who are in the language department, they use AI, and medical doctors use it. And AI can be learned by anyone for that matter. If you have certain mathematics and certain logic concepts, you can pick on it. So that is a way. So at the earliest point in time, that has to be started. And a number of jobs will vanish, especially outsourcing, the back office. A lot of things can be automated. There is something known as robot process automation. It's nothing to do with the robotics. Basically, whatever you do on the screen by the click of the mouse, and you can capture that and automate it. So a human doesn't have to sit in front of a computer, or you don't need a screen. You can have farms, computer farms, in virtual computer farms, virtual spaces where a large number of AI driven systems be doing these jobs for us, and no human is really required. That is the way it is happening now. So there are 15 skill sets that will be taught by 2025. I'm not going to read this again. This is from World Economic Forum, but analytical thinking, active learning, complex problem solving, innovation, etc., are dominant here. So I would like to share that for me, it's a career for lifetime, which is not going to be the same. I have a 26-year-old son. I told him, don't really confine to one area. You need to have a broader knowledge. Then only you can work in multidisciplinary area. So vanishing boundaries of specializations. Why do we need mechanical, electrical, electronics, computer, civil, architecture, biology? They're all, AI will be useful in everywhere, and there will be a lot of interactions, multiple skills have to come. So the future generations have to be agile and ready to learn new skills. So what is ahead? What is that we have to be prepared for? That is the fourth industrial revolution, where every system will be connected. And we call that as cyber physical systems. It's not IoT alone. IoT is the sensing part and the communication part, but the systems, physical systems, be connected. So the future will be complex production systems, which are and AI driven, and they will be self-organizing themselves. That is the world it is going to be. And there are several aspects involved with Industry 4.0. Robots are becoming more autonomous, able to move around by themselves and able to avoid collisions and take care of the safety of the robots as well as the people around. So the space, time, and bandwidth will be shared by humans and robots. So that is the future. And in industries, even the traditional industries, there is so much of data available, but it was collected, but it was not used all the time. But now that data is being utilized because we have quite a number of algorithms capable of managing that big data. And insights will be derived from this data, which will help improving the processes, quality, and delivery throughput, and several other aspects. And to do that, to collect the data, we need sensors, and these sensors could be wired or wirelessly connected to the cloud, where the data can be stored. While we say cloud, it can be local cloud or a global cloud, but typically companies do not want to expose their data to the outside world. So very strict boundaries of security. And for security, the cybersecurity is very important. Blockchain is so hot. And people talk about Bitcoins, cryptocurrencies. So the question is, why do we need banks to manage our money? If blockchain is there where it is authenticated, it cannot be changed, then you believe in that and somebody can provide it. Sometimes even banks can vanish that, but political will is required to really adopt cyber, the blockchains and Bitcoins to become the commodity or the equalizer, like the money that we have. And on the other side, instead of subtractive manufacturing, additive manufacturing or 3D printing is so hard. I have one company which is in Singapore, and my student expanded that to India. So he went to Chennai, Madras in India, to a arts college, and he demonstrated this 3D printing. Then a beautiful idea came up. I just wanted to see how arts and engineering can do wonders. You take your picture and you can have the shape of your face 3D printed, and you have your cake inside that, and that is the gift for your birthday. So that is the way it is going. But there are a lot more applications of 3D printing. And I like to say we have worked on affordable emergency ventilators. We could not do certain parts manufactured quickly, so we did it through 3D printing. And then on top of this, the augmented or virtual reality is making training, education, and even diagnosis quite easy with virtual reality goggles and embedding. Say, if you look at an engine, and it's very difficult to understand what is what and where it is going wrong, but we can relate to identifying individual parts and then relate that to the drawings, then you'll be able to know what is wrong and where to look for what is going wrong. So the factory of the future will have industrial augmented reality to train and also manage staff. IoT sensors and supply chain management will be quite automated, and robots will work along with humans. They are called collaborative robots. The traditional industrial robots cannot share the space because of the momentum with which they hit something that will really damage our body. But these collaborative robots can sense it. Computer vision is so hot. So many companies are into computer vision, and applications are many. So one example is sorting. So we need to have big warehouses these days because of COVID. And how do you really automate it? You cannot have people to do things. And so that is becoming very hard. And currently I'm working on predictive and machine analytics, wherein we get data from processes and we need to predict when something is going to fail. So this is the future, and I'll talk about that more. So AI, augmented reality, blockchain, drones, Internet of Things, robotics, 3D printing, and virtual realities are the essential AI technologies. So traditionally, when we start engineering, we have differential equations, partial differential equations, Laplace transform, Z transform, and we have mathematical models, and we can simulate. And a typical control engineer can do that lot of things there. But now people are talking about collecting data from the physical systems, and this data can become what is known as a kind of a digital twin. And you can have this digital twin to go through all kinds of operating conditions, and you can create data. So for example, two of my PhD scholars worked on data from NASA jet engine. They have a digital twin. They can run that digital twin to failure. You cannot run a physical machine to failure because it's so costly and you cannot run too many times. So the digital twins can be run to failure and collect out of data. And you can see patterns when things can go wrong, and see if certain patterns are triggered, how early you'll be able to detect those deviations from normalcy, and then give inputs so that you can act on it. So that is the way the world is going to be. So cyber physical systems have three very important aspects. Control is essential, computation is required, and communication definitely. So it is a collaborative computational elements controlling physical entities. That is how cyber physical systems are positioned. So they can be monitored, coordinated, controlled, and integrated very nicely. So and also it can add capabilities to physical systems by merging computing communication with physical processes. And there are benefits. Safer and more efficient systems can come out of this. I'll talk about a little more about that. Reduce the cost of building and operating systems, especially if you have digital twins and you can run them to failure and understand how they will work. And also with more confidence, we'll be able to build more complex systems with newer capabilities. Computational cost can come down, and of course, networking and sensing also will become more feasible. So the industry 4.0 will lead to more efficient product and processes. So the efficiency is one pillar. The other is in terms of new marketing and business models. COVID brought that up in terms of innovation. A lot of interesting things are happening around the world. And now stronger customer centricity where agility to design products for the use of people. And the value chain will transform across. So digital twin I mentioned, avatars, could be the future of digital twins, helping to converse with us. So can we have a virtual human avatar? And we may be able to use that virtual humans, and we can do a lot of experiments and see the complexities of, say, something like COVID. And then we may be able to prevent illness. So this is the futuristic one. And the key trends, see 2025, is that connectivity and digitization is top. Hybrid electrical vehicles, battery electric mobility, and those are becoming quite the top trend. So there are changes. So what was first in 2013 has become fourth, and what was sixth has become the top in 2016. Of course, a lot of change in the later areas, a later time as well. And also, when autonomous vehicles and electric vehicles are becoming popular, a lot of jobs will vanish. You look at, see, I don't know about Bangladesh beyond a point, but in India, I know there are a lot of street side vehicle repair people. Their jobs will vanish because if you look at diesel or petrol vehicles, the number of moving parts is hundreds of them. In electric vehicle, it will become 4 the wheels plus the motor, or a couple of more, the wind, screen, wiper, etc. It will drastically come down, and that will remove the maintenance requirement. And the transformation will be very interesting. And everywhere you can try to utilize AI. So for example, can we have a fatigue detection system? And this is very hard. If you look at the truck drivers, most of the accidents are due to they sleeping on the steering wheel. So how do we really keep track of them and ask them to take rest? So this can lead to saving lives. And if you look at machine processes, earlier we used to do a lot of things, with the cutting, vibration signals, acoustic machines. All this can be utilized, and all these sensed signals can be used to provide insights, and you can detect faults, you can monitor surface roughness, avoid crashes, and can lead to preventive maintenance and optimizing the processes. And IoT is transforming industries. So if you look at energy and utilities, we had power networks and grids. But future, it will be a service on demand energy production and consumption. That's the way it is going to be. If you look at automotive, we have cars, but autonomous driving or assisted driving will become popular soon. And healthcare, diabetes pumps, diabetes care will become. And this is happening already. So quite a lot of things are there because of the IoT. And subtractive manufacturing was popular. Now additive manufacturing has become quite advanced. So gearing up for Industry 4.0, digital transformation in manufacturing is essential. Robotics, mechatronics, machining and measurement, additive manufacturing, and manufacturing will go paperless. You don't need to have papers anymore. And analytics should be done on real time. And for that, machine learning will become very important. And so that is the way. So we need to really change our syllabus and change our research to align with this particular futuristic way. And 3D printing is very good and applicable to a number of aspects, right from artworks to complex shapes. Specific materials can be utilized, aerospace, biomedical, artificial bones, teeth, implants. That is the way it is becoming. And there is something known as generative design. Traditionally, different designs will be explored and iterations will be done. And then we have a number of concepts, but too many though, not too many though. And then we need to look at the manufacturability. So design for manufacturing is very important. Design for assembly, design for X we talk about. And then we produce. This is going to change wherein you have a large number of multiple validated manufacturable options. And then when you need to have a particular design required, that will be designed to make and you produce it. So you have more options too. So earlier the options were less, the concepts were less. So this is going to make a lot of difference. And this, I really like this particular picture from the web. This is robot and bridge additive manufacturing. So think of the future that is possible. So why this is happening? We need to ask this question. So this is known as the sliding autonomy. What is that? So there are two ends, simple task and complex task. We have wrong notions about complexity. So for example, can we draw a straight line? Can we walk on two legs? Which is simple, which is complex? From which angle? So we look at from a mathematics point of view, a straight line is very simple, a slope and an intercept. And y equal to mx plus c is very simple from a mathematics point of view, but it's difficult for humans. But robots can repeatedly draw that line 24/7, 365 days per year and number of years. But you cannot draw a straight line, a real straight line. There may be extreme exceptions in humans, but not everybody can do. Majority cannot do it. But we can walk on two legs within a couple of years of our birth. And that's the most complex things possible. I work on humanoid robots. It's very difficult to make them walk on two legs. So walking on two legs is a leap in mankind where two arms were released. And our brain is so advanced and we can walk on earth. That means we are super intelligent. Unfortunately, our education system, A for Apple, B for something else, Bangladesh or Bombay, we teach them. And there we fail people. The people who can walk on two legs and shake hand, hug, make love, that's a complexity to the complex level. And we don't really value that. And we value the marks we get in maths, physics, chemistry, and engineering. So if you look at it, machine intelligence was good for simple tasks and not good for complex tasks. Humans were not good for simple and were good at complex. Humans are more or less same, but machines are becoming good at complex tasks. And this is because a large number of machine algorithms, or there is something called evolutionary algorithms. And this is from the survival of the fittest. So for example, genetic algorithm is an algorithm I think some of you or most of you will be aware of, looking at our own chromosomes, parents mate, how genes are transferred, and how mutation is happening. The same processes can be encoded in binary or other ways, and we can find survival of the fittest there. So quite a lot of things are there, and I'm not going to the depth of it. So artificial intelligence was there as early as 1950s. Typically, it was used for symbol manipulation. Symbols do not have derivatives. So you cannot understand the decay of a banana by the word banana. So derivatives are, or partial derivatives are very crucial to understand the reality. So machine learning came where weights could be changed and learning started. And in 2020, deep learning came into existence. That transformed everything. Different levels of abstraction and representation layers to learn and extract features. So if you look at the Go game, AlphaGo, the world champion was defeated by this machine algorithm. Only the third, if I'm not wrong, the world champion could defeat it. But after that, nobody could defeat it. And the best experts talk about it as that machine algorithm is capable of doing moves which no human on earth will ever consider thinking of. That's a depth to which they can go. So those are not, programs are not written by humans. Those programs are written by machines. They are called extreme learning machines, ELM. So that is the future where you can search for features and hyperspaces of classification and regression is possible, where humans cannot really even consider thinking of. So this is being applied to computer vision, pattern recognition, regression, forecasting, and predictive analytics. And that has transformed. So more complex, growing industry challenges, a lot of data availability, computation technologies have really become so good, and a lot of new algorithms came into. So there are a lot of initiatives for this Industry 4.0, and AI and robotics will be omnipresent. Whichever space you take, entertainment, hospitality, health plans, HR, data science, utilities, everywhere it's going to be. So to give an example, this is from China. 650 employees were there, and they uh, introduced 65 robots, and the number of people came down by 90%. Defects came down from 25 to 5%. Production per person increased from 8,000 to 21,000. But these jobs are lost. But we need to have more jobs created to produce more robots. That's why their education has to be changed. And to facilitate this, what is known as robot operating system. It is not a primary computer operating system. You need to have Ubuntu on top of it. This can be introduced. So I teach this in 2 modules, and students have to create ground and aerial vehicles. And a lot of library functions of common robots and sensors and actuators, you can drag and drop, and you can do wonderful things. The physics engine is embedded, and you can even bring in, say, drawings from CAD software into the space, and you can have your robot tested. And there is also ROS industrial, which is being used in industries. And industry is becoming more open towards it because security is taken care of. And so there are other requirements from an industry point of view is being looked into. So this is one of the works done by a PhD scholar. We have come up with a, common architecture for aerial and ground vehicles. And this work was done in the simulation in ROS, but later we have implemented in a real-time environment with ground and aerial robots. So this is a very interesting work done earlier sometime back. So this is called the interoperable multi-agent framework for unmanned aerial and ground vehicles. This you can see in Complex and Intelligent Systems 2016. So my research areas currently are in machine learning, deep learning, evolutionary algorithms, natural language processing, which are being applied to prognostics and health management, data analytics, and optimization. So prognostics and health management are becoming so hot. And traditionally it is descriptive, then becoming diagnostics, predictive, that is the current state, and eventually it will become prescriptive. What do we need to do? So there are a lot of challenges. In healthcare, a false positive is okay. Somebody is not COVID, but test says he or she is positive, is okay. But in industry, a false positive is not allowed. Something is not good cannot be considered as a product to be distributed. So you need to see the context. And also the discrete data as well as temporal data are available. And in industry, the data that we get is for the good produce. And for the bad produce, it'll be 1 in 100,000 or 1 in a million. So the good data will dominate and the bad data will be minuscule in nature. This is called the data imbalance issue. So we have worked on this, and there are certain algorithms, the minority oversampling in data space as well as feature space can be done. So the misclassification costs will be very high. So if you look at prognostics and health management, from reactive to planned to predictive to prescriptive, we need to have data collection, processing, AI systems to use, and output prediction. And there are a lot of challenges. So the current challenge we face is that how do you convince the middle management and upper management on the return of investment? Because it will take a longer period of time to really reflect, to get the investment, what you do now, how much outflow is there, how you can get that back. And a lot of changes are required in infrastructure. And real-time operations, people don't want to change the existing setups. So quality of the data, noise, whether the data is labeled for supervised learning. And we need to have what kind of algorithm, a large number of algorithms are required. So these are all the challenges. I'm not going into every one of those. So we have a number of publications. You can go through our Google Scholar and try to get it from there. So this is about the ventilators. I'm coming to the end. So 3 of companies, 2 of my companies in Singapore and a company in Kochi, Kerala, came together to develop affordable ventilators. And we use open innovation. This is so hot in Industry 4.0. Don't have a closed boundary. We cannot have every knowledge, so we have to open up. We developed the AMBU-based, pneumatic-based, and also splitting a ventilator to 2 patients. So this is now being produced and distributed. A number of people came from US, India, in fact, Professor Mamun was helping in Indonesia, UK, Europe, and other places. So a number of people helped us, and the old IQ is about how smart a person is. The new IQ is how smart you make your team. Number of people came together. That's my son. He shaved his head, so I started shaving my head. That's why I'm bald today. So that is my story, and I would like to stop here. And any questions we can have now.
I'd like to thank Professor Prahlad Vadakkepat for wonderful talk, and this discussion is now open. Anyone are welcome to ask question.
I hope
Yes,
I was on time, I hope, yeah.
Yep. We have got Professor Dr. Ajay Krishna. Please ask questions.
Hi.
Okay, thank you very much. Please tell me if I am audible to all of you. If you could hear my voice, please tell me.
Yeah, I can hear you.
Yeah, first of all, I have one question. You have mentioned some sensors. So could you give us some examples of sensors that can monitor or diagnose any biological function, say emotion, perception, understanding, hate, rage, love, and so on?
So which application is this? Is healthcare application?
Yeah, it is for healthcare.
Yeah. So I may not have the list, to be frank with you. So, so if you look at the ventilators per se, we did not use, of course, because of COVID, there were constraints, so we could not get the things, to be frank with you. So we used what was available in India, and that's a good thing. Okay. So what is happening is that, though I may not be able to give you the specific sensors, but what I'm trying to convey is that even if you don't have the best sensors, the algorithms can help you to have better measurements and control. So this is one aspect which I noticed there. So if you look at weight measurements or health related, there are quite a number of sensors. Is that Dr. Ajay you're talking about, is specific to?
Yeah. I am interested in healthcare actually. Actually, to monitor biological function, say I want to monitor his or her emotions, perception. That is the thing actually.
So
And another question, I got your answer. You don't have the list right now. Another question, you are telling us safe driving. Safe driving. So in case of safe driving, uh, could you please tell me the features of those sensor could be installed in the driver's body or in the car? I mean, what are the ranges of frequency and some other parameters?
Yeah. So LiDAR is very much important because we need to have range sensors. So LiDAR is a laser range finders. So there are multiple sensors of that will be required in the front, back, or top on the sides. And this is a very costly one, but it is becoming hard, and the cost is coming down. And people also use vision, and vision helps in certain other ways to understand the features. But night and daytime, we need to be very careful. And also there will be other communications between the vehicle and the infrastructure, as well as vehicle to vehicle. So all those sensors typically be able to make the system. It's not, we cannot say a vehicle is intelligent. It is the infrastructure and the system that is becoming intelligent. So eventually the traffic junction lights will go away, because traffic junction lights are for the humans to see it and act on it. So when vehicles become autonomous, why do you need all this? So certain things which are required for humans to operate may vanish or may exist to a certain extent. But vehicles to become autonomous, basically you need to have distance, you need to definitely GPS is required, but GPS alone is not sufficient. So you need to know the location with respect to whatever map you have. So multiple sensors will be useful. So we use, say for example, GPS. We have initial measurement units. can also have encoders. We can also have camera-based landmark detection to identify where you are. So quite a number of multiple layers of sensing might be required. This is to make the system fail safe.
Okay,
So
I got it. I got it. Thank you very much.
Thank you.
I have another question is that you are telling about the sensor. I think those sensor could have some fixed database. If the situation is different, or if the situation, the constant is different, when a person is driving his autonomous car, or yeah, in that case, maybe the sensor could not work well, because the sensor works as some data set or some inbuilt data set, some map or some other the facilities are available within the sensor. So if something uncontrollable, that's uncontrollable situation happen within the roads,
Vehicle. Oh,
how
yeah.
could we solve this problem?
Yeah, so if I understand the question correctly, maybe I rephrase it. So there is a lot of data being sensed by the, say, for example, autonomous vehicle. And if something goes wrong, what do you do, right? Is that the question?
Yeah, that's right. Yeah.
Okay. So this is a very interesting point, very important. And we have, I'm getting into a big project on this. The connectivity is lost, and how do you control? There is one part.
Yeah.
And edge computing is becoming very popular. So autonomous vehicles cannot rely completely on cloud. So you have to have local as well as cloud support. And if the cloud support is not there or connectivity is not there, it should be operational for at least for a certain period, or at least till it gets to a point where it can get support, where with the help of local computing and sensors. So this will be definitely there. So, but however, the data, whatever is being collected, there are ways to really safeguard that. So people look at how to, just like, black box in a aeroplane, can we have something that cannot be tampered with even during an accident? So that is a way. But if more vehicles become autonomous, the accidents will come down. Accidents are mainly because of the errors, typical human errors, and their emotional being, state of being, and hurriedness and distraction. So when you have autonomy and the infrastructure is ready, the accidents will come down. That's my way of thinking. Yeah.
Okay, thank you very much. That's it for me.
Yeah.
Thank you. We have another audience question. Mahit.
Okay, thank you. Thanks for giving me the floor. The keynote speaker, thanks a lot for excellent talk. In data collection, you have said about imbalanced data set. There exist techniques like oversampling or undersampling to solve imbalance problem. My query is, how can I understand whether oversampling or undersampling will be perfect for a specific imbalanced data set?
That's very, very interesting. So typically, if you if you know the industry or the process where the data is coming from, and naturally you will know how many samples are going bad and how many are going good. The percentage will be available. So we have got data from industry, we work with the industrial data. And so upfront, we knew that it was an imbalanced data. And then what happens is that the good data dominates, then the classification boundary will be drawn towards the good data, which may not be right. So that's why we need to go for oversampling. So when you do oversampling, the issue is this. If you sample in data space, the new data that you get in database, in something like interpolation, may not have the same features as that of the data from bad production. That's why what we have done is we have tried to convert this data into feature space. And in feature space, we sample it the features are preserved or conform to, then that data you get will not be wrongly classified. So that is there are of course multiple ways of doing it. This is one of the works we have done. So people are increasingly preferring to have oversampling done in feature space. And undersampling is for the majority data. You don't need to have the lot of data to use, but sometimes how much you can undersample, right? And you don't want to undersample also sometimes because you need to make use of the data. Of course, there is a give and take there. Yeah. So Mahit, did I answer your question?
Yeah, thank you. We know that in oversampling, there may be overfitting, and in case of undersampling, there may be undersampling. How can we handle this oversampling problem and undersampling problem?
So
how can we measure this, right?
Yeah, so oversampling is because the domination of the particular data for the good produce. So whether we can avoid it or not, that is a question you are saying, right? Sometimes, I mean, my experience with the data from industry is that the more the data, I'll be more comfortable to come up with situations where things will go work well. I need to know that exhaustively. So I may not undersample. Okay, that is one way of perspective. Oversampling is if you have the minority data, then I have to create data, synthetic data. So that is where I talk about the interpolation and the synthetic data is being generated in the feature space. So it is not very easy to say for a specific data, one is good or one is bad. You have to work with the data and understand it. So that is my understanding of it. Yeah.
Okay, you are trying to say that oversampling or undersampling is data specific.
Yeah, correct. Yes, thank you.
Okay, thank you, sir.
Yeah.
Any other questions? We still have a few minutes.
I have not a questions actually. I actually want to know from Professor Prahlad, and also would like to thank him very, very much. I mean, it was really an excellent keynote session that I have witnessed. I could see the future from your talk. It's really an encouraging talk, especially for me, I guess. So, Professor Prahlad, what I was thinking, when we are going to get Industry 5.0, or I mean, Japan is using Society 5.0. Yeah. So, are we going to get Industry 5.0 or something like other?
I think the time for the next innovation will be reduced, the gap, because with the progression it is happening. So earlier we used to predict for 20 years, then 10 years, now 5 years, and soon it will become 3 years because we may not know beyond 2 years or 3 years. That's the way the changes are happening. And what I understand, I work with a number of companies, right, from US, Singapore, Korea, Europe, and India, and Singapore here. A lot of companies are not even Industry 4.0 ready. Many of them are not ready. And digitization is not easy because they have to invest a lot. And the middle level and higher level management are used to the traditional way of doing certain things. The return of investment is good. They cannot disrupt that particular process. This is natural, So that's why, our education system has to change. So we have Industry 4.0 master's program here to really help the working professionals to go through and understand Industry 4.0. So I think it will take some time for Industry 4.0 to stabilize and pervasive. This is one point. But however, the COVID has accelerated it like anything. So in certain sectors, especially say healthcare, manufacturing, even we are talking about, see, for example, Singapore relies a lot on foreign workers from developing countries for construction and maintenance. And we had a lot of difficulties here. So people are talking about how to automate in civil construction. That became to the forefront and actively pursued because of COVID. So certain sectors will be accelerated, and a lot of work is happening in that space. A lot of funding from international agencies will come in for research in that direction. So Industry 4.0 will be a mixed bag as far as my knowledge goes at this time. Certain sectors will accelerate very fast. So I'll tell you one extreme other situation. In Kerala, where I come from, that district has a number of steel mills. They use very old, it is not even Industry 3.0 or 3.5. And their power factor issues are so bad. They use so many, what do you call it, the capacitors, and that cannot manage the power factor correction. And I visited them 10 years back, and I suggested something, and they said, Prof, we are making a lot of money, it's the crores, the crores of rupees per year. I don't want to disrupt it. I'm having a wonderful life. I'm sorry, this is recorded. I'm saying this on a public platform, but that is a mindset. It's not easy to change. So how do you really leap forward and embrace the newness? And that is a question mark for certain sectors. This is my feeling. So Sajal, Industry 5.0, I don't know, to be frank with you, but it may be sooner than what the gap from 3 to 4. So 5 will be earlier. That's my feeling.
Okay, thank you. Thank you, Professor Prahlad. And thanks for accepting our invitation. I mean, Professor Mamun actually was my supervisor. So
you work with Mamun?
Yeah, yes. I was also in NUS as a.
See, I sit next to him. We are neighbors for the last 20 years. You didn't see me.
I actually worked with Prof. Bhatia.
Bhatia. Oh, I see. That's why we did not cross the roads.
He left NUS. I know. But I also worked with Prof. Mamun as well in a different project, especially on hard disk drives control. Yeah.
So that is going away. That industry is no longer going to be there, right?
After submitting my PhD thesis, I was there. Yes.
I see. So nice to see you, and thank you for inviting. And the beginning, I was saying, I'm originally from India, but I could not visit the neighboring countries. I visited a lot of countries. It's quite sad, but we need to be.
It's really honored, Professor Prahlad, because when I was seeing your talk, I mean, many of our students, have been working in that field. I mean, through your talk, I guess not only me, even the faculty members or other students of especially our department will get new dimensions. And definitely there are lots of areas which can be focused. So in future, if it is possible for you to have a research collaboration with us, that would be very, very nice of you. I talked with Prof. Mamun regarding some of our future plan. He agreed to work with us in collaboration. So with you, I think it would be the best.
So Professor Mamun and I, we work together in a number of things. So I'll be very happy to. And, it is giving back to the community, and I'll be very happy to do that. So we can explore it. We'll discuss further. And
okay. Thank you.
Thank you very much.
Okay. Honorable Session Chair and Co-Chair.
Yes. Thank you, Professor Vadakkepat. And we have learned a lot of things of where we are right now, and what is the future, and what is going on in the world. So the Industry 4, that's what we understand, that some of the country or some of the industry or some of the university is going too far. And like Kerala, Bangladesh, and some poor country, we are still in the era of 2 or 3 type. So it is very difficult to cope with these two types of scenario. Like USA, what is happening in the USA and what is happening in Bangladesh, two different scenario.
Yeah.
It is right now it is very difficult to match this scenario. Otherwise, industry 4 or 5 will not be sustained. If US go further, and they need a lot of products from Bangladesh or India or the country like this. So we have to also come up with this to cope with the situation. Otherwise, the whole system will fail.
That's true.
So anyway, we have a lot of challenges coming. They say some of the things we have seen them maybe in the next few years, the 10 years or 20 years, the USA or Australia, Japan, they are going too high, 5 or 6 maybe, but still we have to come up with this. Otherwise, the whole database will be the different scenario. Then it is very difficult to connect each and every facility to use them. So anyway, this is the good presentation. We have learned a lot of things and what are the challenges in future. So maybe we can come up with our syllabus or our understanding to cope with the situation. And the similar thing like Kerala in Bangladesh, in the